Good morning, world. Another day, another interview question. So today we'll be tackling through the design section on LeetCode. So these problems may require to implement a given interface of a class and may involve using one or more data structures. These are great exercises to improve your DSA skills. So yeah, let's get into it. I think the design questions are a little more what they should be looking at for JStreet. So let's get right into it. Shuffle an array. Given an integer array nums, design an algorithm to randomly shuffle the array. All permutations of this array should be equally likely as a result of the shuffling. So all permutations is telling me maybe I can do some permutations, some backtracking, implement the solution class. In it, initialize the object with integer array nums, resets the array to its original configuration, returns it, and shuffle returns a random shuffling of the array. So permutation screams out backtracking to me, so I will do backtracking and then I'll randomly pick one from it. Okay, so let's first initialize our arrays to nums. Um, for reset, I think we can just return the array. And then for shuffle, what we might do is we're going to create a recurse function. Let's try the backtracking. Let's try the backtracking. Uh, let's try the backtracking approach. So what would the backtracking approach look like? What it would look like is that let's say I have an array of 1, 2, 3, 1, 2, 3. For each array, so I'm going to have all the possible outcomes is 1, 2, 3, and then another one might be 1, 3, 2, another might be 1, so that's it for that, so it might be 2, 1, 3. So what I need to do, let's see what I'm going to be outputting. I'm going to be outputting a list of integers. Yep, so let's have an output list here. Right now, we're going to check if length of the array that we received is equal to the length of the self.array. Oh, then let's have an output shuffled as well. Then we're going to append this to our shuffled. So if the length is the same as the array, then we're going to append it to our shuffled. Yep, this makes sense. So we'll be adding it to, so inside here we'll have 1, 2, 3, 1, 3, 2, and 2, 1, 3. And then we're going to return after this because that's it. Now another case is that we need to go through every number in it. So let's look at this case here. So we need to go through each number. So for I in array, in range length of array, so we're actually going to have the running array and the remaining array. So we're going to have a running array and the remaining array. And then inside there, we're gonna call this. It's going to be a recursive function. So inside here, we're going to do running array. We're going to add whatever element we are at right now, plus array I. So that's going to be the new running array. And now we need to pass through the remaining array as well. So that's going to look like, yeah. So it's going to be everything except for this right now. So apple, if I do 2, it's going to be if I put I at the front, what does that look like? 2 and everything onwards, right? So, damn, I always get this confused. Okay, let's see. So let's say it's going to be CDE. Do some list comprehensions. What would this print? CDE, this prints AB. Yeah, CDE, and it's going to print AD, AB. So, so if it's 2, no, if it's, so it's 1. AB, it is, okay, so this is index 0. So for it 1, it just prints AB, right? So it doesn't, we don't get the number here, so which is fine, which is good. Wait, 1. Let's say we're here. We don't want to get this, so 1. So it's going to print that 1 plus array. Wait, what if it's 2 here at the front? CDE. So let's say I don't want to. So let's say I'm at C, right? Okay. So this has to be. So I try to add 1 here. This doesn't actually return anything because it's just gonna modify our shuffled array here. Yep, that looks good. And then we're actually gonna call the recurse function here. Recurse is gonna pass through an empty list, and the remaining array, which is just gonna be self.array. And then we're gonna have a list of all the random permutations. So it's gonna be random.choice return random.choice of self.shuffled. Name array is not, oops, no, remaining array. So we're going to be passing through the current running array plus what's existing of the remaining array. Memory limit exceeded. Okay. Hmm. So we can't use so we can't, let's think about it then, okay. So if I do for I in range, length of a remaining array. So this is going to be nothing. Is it going to be nothing? Wait, that might not be nothing. That probably is nothing. There's nothing here. So this means everything up until this point, and this means everything from this point. If I do 1, it's up until 1. Maybe C, D. Young, 0, 1, 2, 3, 4. So everything, okay. So if it's 1, everything just before that number. And this means, yeah. Should we have a look at the little hint? Wait, the problem is that when I do call shuffle, I need to reset the array. I'm not sure if that changes anything, but let's see. Hmm. Memory limit exceeded. What does that mean? Limit exceeded. That means memory limit exceeded. Memory limit exceeded. That means our recurse function is not leaving properly. Okay, let's see it for this specific case. So we have, yeah, we have that. So it's going to go for 11 times. So it's going to be the current running array plus whatever we have one right now. Is not a backtracking question? Hmm. Okay, so it doesn't seem like permutations is the way to go. Fisher-Yates algorithm. If we put each number in a hat and then draw them out at random, the order and hmm. All right. So seems a bit much more simpler than I thought it had to be. Let's try code it out. Uh, so what this actually means is that for each number we're gonna do a random. We're gonna choose a random index ahead of it, and then just swap it with that because then that's random. Random range. Okay, so okay, I guess yeah. Let's see, why do I have to swap it with... it's because if we swap it, that means we've already selected the number for this position. Like we've already drawn it out of the hat. Okay, well, interesting shuffle and array tactic. I guess that's pretty random. I asked ChatGPT before it. I see, so I did it that way. But the permutation one also makes sense. Backtracking. I'm guessing the backtracking approach that I did is also viable if we had more memory or such. Let's see. Okay, so yeah, shuffle and approach.